Okay, let's start the new unit. We're going to do probability and statistics for the rest of the year, and then that's basically it. So we're just looking at data. The idea is you're collecting data. That's what you do as a statistician. Someone has to collect it, and then we're going to analyze it. So there's two types of data. The first type is qualitative, which is also known as categorical. So there might be data described by the color or the brand, or what are the types of ways people get to school, and so there's cars and bikes and walking and airplane or something like that. But so the idea is described by characteristics, like a characteristic. So, for example, like color, brand, like a specific item, but it's by a word. Now, in this class, so this might be in your science class, like, the types of, describing the types of plants, 3 leaves, 4 leaves, the colors of the flowers, something like that. The other type of that we're doing in this class is called quantitative, and this is basically described by numbers. How many? That's what score did you get? How far did you run? How much rain fell? How much rain fell in a certain city last night? What's the temperature? How much do you weigh? Stuff like that. How many of these? So it's described with numbers, and it's called numerical data. And so there's two types of, and we're going to be studying that obviously because we're a math class. What's the two types of? The first type is discrete. That's what we're going to be talking about today. And the other type is continuous. And discrete, basically, simply you count it, countable. So how many kids came to school today? How many people live in Gulshan? How many kids in AISD are in the 9th grade? How many kids come from a certain country? It's countable. The next thing we're going to be talking about is the other thing is continuous, and this is measured. So the idea is we really don't know the exact, but we measure. For example, how old are you? Well, you might say, well, I'm 15. You're not exactly 15. For example, are all the 15-year-olds in the class the same 15? You'd be like, no. Like it's somewhere between like 15 and 16. Maybe you might say, 15.528 or something like that. But the idea is we measure it. What's the temperature? We know like 30 degrees Celsius. There's no exact 30. How tall are you? You're not exactly, like I'm American, it's like I'm 5'7". I'm not exactly 5'7". That's the idea. So this is countable. Yes, it's countable. This one's a measure, for example, weight, age, distance. Okay, so the next thing we want to do is, so we've collected the data. I want to give a shout out to the new student, May. She's new in our class. So, yeah, welcome to the class. This is how we do it. I just give a lecture as if I'm standing in front of the classroom. You watch it at your own pace, take the notes, and you'll answer the questions in the book. Anyway, let's go on. So, the next thing we want to do is organize the data. Organization of the data. And so we're going to talk about discrete data today. Let me move this down a little bit. So the idea is you've gone out, let me lower this to right. So the idea is you've gone out, maybe you've created a questionnaire, you've asked a bunch of questions, and you've collected some data. So let's say you're a teacher. So one thing we're going to talk about discrete. And the question is, how many questions did you get correct? Correct. On the 3-question quiz. And so the first thing is, so we're going to make we can collect all this data. So maybe, here's some responses I got. You don't need to write this down. So I'm going to write it down, but then I'll say it over again. So let's see, 0, 1, 2, 2, 3. 3, 2, 1, 0, 0, 0. 3, 3, 0, 3, and then let's see, 0, 0. These are the scores. So the question is, how am I going to organize this? Because I don't want to, if someone asks me what the scores are, I don't want to read. How many scores? Like 17? What is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I don't want to say all 17 scores. I want to be able to organize. So the first thing we're going to make is put it in a column chart. So the first column is going to be the score. The next column, you don't need to do this. You're going to be given this, but this is old school. We'll take a tally. So for example, so it's like the tick. So the score is like, what do we have? 0. So let's see, what are the scores? 0, 1, 2, and 3. Okay. And then what we're going to do is we're going to put them in the chart. But first we do a tally. So maybe you'll read them off to me. It's like 0, 1, 2, 2, 3, 3, 2, 1, 0, 0, 0, 3, 3, 0, 3, 0, 0. Okay, so it's a little more organized for us. So let's see, next comes the frequency. The frequency is the number of times the value occurs. It's the number of times the value occurs. And so you're like, fine, you can count that up. You'll be given this because IB doesn't want to waste your time on this. So the idea is, let's see, here's 7, here's 2, here's 3, and here's 5. Now what I would do is a couple of things that I might ask, and it's just, first of all, how many data points were there? This symbol here we learned in the series and sequences unit, that symbol means the sum. So we add these up, we have 17. And then something else that might occur, this is known as the relative frequency. The next column may be relative frequency. And so, well, we can talk about it. It's in the book. So let me erase this, sorry. Something called relative frequency. And the relative frequency is the percentage that the data occurs out of the whole. It's very simple. Simply 7 out of 17, 2 out of 17, 3 out of 17, and 5 out of 17. And if you add these up, you'll get 100%. That's the idea. But this is how we organize that in a chart. What are some questions I could ask you? The one thing I'm going to ask you, what's the mode? What is the mode? And that's the data that occurs more than the others. And so we see here the mode is 0. Okay, a couple of other things. What's another? So this is the idea with statistics and data is we want these visualizations. We want pictures. So the first thing is we have a chart. Is there another picture we can make? And the answer is yes. We can make something called a bar chart. So let's take our data here and make a bar chart. Let's see. So May, you can pause the video to copy this down. I'm going to erase this, but you have it in your notes. If you don't copy, obviously, pause the video. So So the idea is that's what we want to do is to make a bar chart. I'm sure you've seen this before. A bar chart. It's also known as a column graph. And we know that it looks something like this. And the idea is along the side is the frequency. So look, we have like 0, 1, 2, 3, 4, 5, 6, 7. And then along the base, I'm going to do we have the actual events, right? So here's 0, 1, 2, 3. And the idea is we're going to make bars. So 0 is going to go up to 7. 1 is going to go up to 2. 2 is going to go up to 3. And 3 is going to go up to 5. A couple of things. It's not the best graph. You're generally not going to be asked to do this. Just remember the bars, these bars are equal width. And also remember there's spaces between between these values, because there is no like half a question right in this class, or there's no like 2.83. It's like 0, 1, 2, 3. So when it's discrete, and you have the bars, they have to be separate. Good. Two more things. Now, so my chart, a lot of kids did poorly on this test. So this thing happened. Then in the real world, most kids get like the middle or the average. We'll talk about that. And so if we look at the data, it's supposed to look like this. And this is not as the distribution, right? The question is, how is the data spread? And in this case, you would say, oh, there's symmetry. In this case, it's symmetric. So let's imagine these are scores on the test. In this first case, most of the scores are in the center. Some kids did really well, and some kids did poorly. Now let's take another scenario in which what happened here. Here's the bar chart for this. What's going on here? Well, this is known as it's skewed. This distribution, it's called skewed negative. And when you see something like this, you say, oh, the test was really easy. Most of the kids as well. The test was too easy. Most of the kids did really well. Another thing you could view is maybe the data kind of looks like this. In this case, now another thing you might see is something called a bell curve. We'll talk about that in another class. But here, in this case, we say it's skewed positive. And you would kind of say to yourself, oh my God, that test was really hard. All the kids really didn't do that well. The test was too hard. And so that's the idea. So that's the idea of distributions. The last thing I want to talk about this idea of an outlier. So you're going to be looking at data sets for homework, and most of the data is supposed to be within like the range. Like most of the kids in the class are kind of supposed to do around the same. But every once in a while, and maybe you've learned this in your science class, you're going to get a data point that just does not seem like it belongs. And that's known as an outlier. An outlier is a data point. What did I write? That is very far away from the others. The other points. Now, let's see, far away, sorry, really sloppy handwriting. Far away from the other points. Okay, now clearly that's not like a really good mathematical definition at all, like that, and we're going to get to it. But the idea is in this section, you're going to be, organizing the data and maybe making a bar chart, and then you're going to have to decide if that one piece of data is like so far outside that it's called an outlier. As I said before, this is not a mathematical definition. We're going to come up with something. Yeah. So after the video, you are going to do the problems that I put in the assignment. So good luck. And if May has any questions, she should be able to ask anyone in the class. And everyone during this 45 minutes, you guys can talk to each other. You can talk to anyone in the class. As long as it's not a test, I'm fine with group conversation or talking. I don't do breakup rooms, stuff like that. Anyway, good luck.